Hello everyone. In this video, I'm going to cover the assignments for week 12 of the course. We talked about graphs and different graph implementations, adjacency matrices, and adjacency lists, and we covered breadth first and depth first searches to traverse through our graph implementation. This week, the reading is Miller and Raynham 7.1 through 7.18, and also do the participation activities in Zybooks sections 5.1 through 5.7. Let's take a look at programming assignment number 6. This is the last programming assignment for the course. So PA6 is titled Graph Mining. We're going to construct some graphs, and we're going to do some mining of the information in them. The learning objectives for this assignment is to implement breadth first search for graphs, visualize graph structures, and compute graph statistics. So prereqs for the programming assignment include, of course, being familiar with object-oriented code in Python, being able to implement a graph abstract data type, and some common graph algorithms. We cover this in the lessons, and you'll be writing this in Jupyter Notebook and creating some plots with Matplotlib and NetworkX. Overview and requirements for this assignment. We're going to tackle the important social network problem of finding an actor's Bacon number. You can go ahead and click on this link if you want to find out more about the Bacon number that I'm going to describe here. So for finding a Bacon number, an actor's Bacon number, we're going to start with an actor, see if they have been in a movie with someone who has been in a movie with someone who has been in a movie, ... so on and so forth, with someone who's been in a movie with Kevin Bacon. They're usually at most 6 steps away. So when you see this 6 steps away, you can think about this as being a distance in a graph where the vertices in the graph are actors and the edges are has been in a movie with. Here's some more description of the 6 degrees of separation phenomenon in social networks. You can continue to read about it if you would like. So for this assignment, we are going to have one Jupyter Notebook that tells the data science story, and we're going to have auxiliary files, .py files, to contain the graph classes and functions that we don't need to have in our story for our Jupyter Notebook. And you'll be sure to import that those .py files into your notebook. Program details. So you're going to write a program to play the Kevin Bacon game. The vertices in this network graph are actors, and the edge relationship is appeared together in a movie. The goal is to find the shortest path between 2 actors. So traditionally, the goal is to find the shortest path to Kevin Bacon. So Kevin Bacon will be your starting vertex. The following output from the sample solution shows how the game is played. So here's some output here. Prompt the user for the name of an actor and find out what the actor's Kevin Bacon number is, and then show the path from this actor to Kevin Bacon. So let's talk about how you're going to compute this shortest path to figure out the distance for the Kevin Bacon number and the actual actors along the path. So the easiest way to do this is do a breadth first search, BFS, we're familiar with this, in the movie data graph. This builds a tree of shortest paths from every actor who can reach Kevin Bacon back to Kevin Bacon. Or more generally, given a root, BFS will build a shortest path tree from every vertex that can reach the root back to the root. It is a tree where every vertex points to its parent, and the parent is the next vertex in a shortest path to the root. So one thing I want to comment about that in class, we implemented a BFS, but by process node or process vertex, we were just printing out the vertices. Our implementation from class of BFS does not build a shortest path tree. Later in the course, we're going to implement Dijkstra's algorithm for a weighted graph. Dijkstra's algorithm does build a shortest path tree. So for this assignment, our graph structure is unweighted, so we can use a breadth first search generated shortest path tree or a modified version of Dijkstra's algorithm to generate a tree. Now, Either one of these options will work. If you choose to go with the Dijkstra's algorithm option, you will need to read ahead in the notes to find out about Dijkstra's single source shortest path algorithm. So I recommend doing this first part, the description here, augmenting our breadth first search to build a tree as you're traversing through each vertex in the graph. Here's the algorithm to build this tree. So the shortest path tree in a breadth first search can be built using this pseudocode. It looks very familiar to our BFS code in class, except we need to build a new directed graph, T, and we need to add vertices and edges to T in a certain manner based on breadth first search. When you have implemented this algorithm and your algorithm is bug-free, T will hold a shortest path or BFS tree. To find the Kevin Bacon number of an actor, you can look the actor up in T. If there is no vertex for that actor in T, then the actor is not connected to the root, and the root is Kevin Bacon. If the actor is there, then follow the edges of T back to the root, printing out the movies and actors along the way. Now, the movies will be the edge labels, and the actors will be the vertices. So you can see why this is going to be a directed graph, because we're going to need to connect each one of our vertices to its parent in the tree to find our way back to Kevin Bacon. The dataset to use is available in bacon.zip. It contains 6 files, 3 main files, actors, movies, and actormovies.txt. They're quite large. In total, there's about 21,000 movie actor pairs, which results in 32,337 edges. I said there were 6 files in bacon.zip because there are 3 smaller versions. These are test files. These are the files you're going to want to practice on and write your code and develop with before working with these much larger files, because these small files will be easy to debug. So here are the vertices in the test files and the edges in the test files. The following text is going to describe the way the files are formatted. They're actually formatted using IDs and names, so you will need to implement some dictionaries in order to keep track of the IDs and names for lookup purposes. Okay, the Bacon game. You're going to implement the Bacon game by performing a breadth first search on the graph with Kevin Bacon as the root, and you're going to hang on to that BFS tree that is returned. Then you're going to prompt the user for an actor. For each actor they enter, you're going to print out the path between that actor and the source, or say that none exists. And you're also going to print out the length of this path. Path visualization. Using a Python library for visualization, such as NetworkX, which is covered in the course, visualize the path from the user-specified actor to Kevin Bacon. And each one of the vertices should be labeled with the actor name, and each one of the edges should be labeled with the movie name that they both start in. So for example, Owen Wilson's Kevin Bacon number routes Owen Wilson through Ben Stiller and Kim Dickens back to Kevin Bacon. So he is 3 actors away. Next, additional functionality. This is our graph mining part. Compute at least 2 interesting statistics about the graph. I list some possible examples here, but you're a data scientist, and I would love it if you could choose your own statistics or own questions you want to ask about this graph. Simply in your Jupyter notebook, describe the question you're asking and the statistic you're going to compute, and then have your code to display your result. And be sure to describe your result as well. Some bonus here, using a more recent data set, if you would like, and submission and grading guidelines. So your zip file will contain your Jupyter notebook file that's going to tell the story of your data, your Kevin Bacon data processing workflow. your .py files, which will have all of your graph class code and your auxiliary functions, and then all 6 txt files and possibly more if you do the bonus that you use to test your program. All right, last programming assignment, so go ahead and get started and have fun with this one.